Welcome to Computer Programming with Sharon. We are continuing with some more examples over there. In one of the previous class, we discussed Armstrong number or not. So I'm taking the same program here again. The explanation is already given over there. What is Armstrong number and how to find out. So here directly I'm just giving some numbers over there instead of using scanner. So here it will print whether that number is Armstrong or not, right? So if it is Armstrong, it will print Armstrong or not Armstrong, whatever it will print over there. Now I need to modify this with print Armstrong numbers from 1 to 1000. So that means this in value I should change from 1 to 1000. Then inside that loop I can just put the same thing over there. So I'll get the solution. So here we are going to print Armstrong numbers. So here we are trying Armstrong numbers from 1 to 1000. So I'll write the program here using for loop itself. Already n is declared over there. So I should change that n value from 1 to 1000. And entire thing is putting inside that for loop like this. Now, before checking this Armstrong or not, we have to reset the DS value over there. Digit sum that should be equal to 0. So here I don't need to give again. And t value, here actually t value we are taking from here, but n value we should change from using this loop. We have to change the n value. So there is no meaning of assigning t equal to n over here. So that also I am giving over here t equal to n. So the new values of n I will get again. And again, if it is not Armstrong, we don't need to print it. So I can avoid that portion. And I don't need this message also. If n is Armstrong, it should print that number. So using the first loop, we are changing that n value from 1 to 1000. And digit sum we are initializing 0. T, temporary value, that is the new value of n. And this is the program for checking Armstrong or not. Inside the first line, we are taking the last digit, then terminating the last digit, then last digit cube we are adding into the DS value, digit sum value. So this will work till t becomes 0, and outside we are checking whether that n is equal to the digit sum. If it is so, it's an Armstrong, so we should print that. Now just check the output and see whether it is working or not. Yeah, we are correctly getting that 1, 153, 370, 371, 407. All these are Armstrong. So we already got the solution to find out Armstrong numbers from 1 to 1000. Now the next we will try to print the factors of a given number. Factors of a given number means the number which is divisible. For example, if I am taking 5 as my number, 1 will be completely divisible because 5 divided by 1, I will get a remainder 0. But 2, I will not get 0. 3, I will not get 0. Like that. So only 1 and 5 are there for 5. If I am taking number 6, 1 is divisible, 2 is divisible, 3 is divisible, and again 6 is divisible over there. So I will get 6 factors as 1, 2, 3 and 6. 4 and 5 will not correctly go because if you are trying like n percentage 4, you will get balance as 2. So it's not possible. Then 5, you will get a remainder 1. So that 4 and 5 are not factors. So how to check those? I will write over here. Here I am declaring a variable n and giving the value of 6. I need to print the 6 factors. We will try to use the for loop itself. And I value is changed from 1 to that number. And we have to check whether I is divisible in n or not. So n percentage I equal to 0. If it is divisible, we have to print the I value. Let us check the program output. Here you can see 1, 2, 3 and 6, right? So you can give any number over there and you can run. So you will get the factors of that number. Now the next thing I want to discuss about the prime numbers. Prime number will have only 1 and that value will be there as factors. For example, if I am taking 5, you can find out this 1 and 5. Only 1 and that number is divisible over there or factors are there. If I am taking number 7, I will get only 1 and 7 only. So these type of numbers known as prime numbers. If I am giving 9, other than the 1 and 9, I am getting 3 also. So this is not a prime number. So we will modify this program to check whether the given number is prime or not. Two results are there, yes or no type. So we can go with the boolean type. I'm giving the variable name as is prime itself and giving the value as true by default. So we are imagining the given number will be a prime itself. And we have to check from 2 to less than n only, because we have to avoid factor checking of 1 and that number. Other than 1 and n, if any other factor is there, then it's not prime. So we can say is prime will be false in that case. Now outside the for loop, we can cross check is prime. It's a boolean variable, so no need to give double equals true. If it is true, we have to print that n is prime. Else we can print n is not prime. So we'll just run and check the program whether it is correct or not. Here is saying 9 is not prime, right? 7 will give 7 is prime. So this program is working perfectly. I will explain one more time. This will check any other factor is there for n other than 1 and that number. If we can find out any other factors, then that case the default true value of is prime will change into false. So in case this is changing into false, that means it's not prime. If it can't find out any other factor, that means like it's a prime, so this will print this one. Now we can modify this program and can print prime numbers up to 100 or 1000 or up to the given number. So this entire thing we need to put into another loop. So again I am using a for loop over there. There I will try to change the n value from 2 to our range. Here we are not starting from 1 because 1 is not prime or not prime. So we can avoid that number. Now just imagine like I need to print up to 10. I can give the level as 10. So first we'll try with the 10 value, n plus plus. Now this entire thing I'm putting inside this outer loop. So prime or not checking is already given over there. And now the n value, instead of giving a constant over there, now we are changing there. N value from 2 to 10 we will change. Now one more thing, this resetting portion, that also should be inside this loop itself, because we have to reset before checking each and every number. Now we need to print the prime numbers and not the non-prime numbers. So we can avoid the else part. If it is prime, we have to just print that numbers. Now this n will change from 2 to 10, and if that n value is prime, then it will print. We will check that. See, up to 10 we are getting 2, 3, 5 and 7. If you need more numbers, then you can change this into 100,000, whatever. Now we can see like these are the prime elements up to 100. So like that you can modify and check it. I think you got the idea. If any doubts, please put in comment. Please subscribe, share and like the channel. With more example, we will see in next class. Thank you for watching.